Hi, I'm David with General Air. When you're MIG welding, eventually you're going to run into some gaps that you have to fill. We're going to take a look at how to set your machine and what to look for when welding some thin gaps all the way up to some pretty big ones. The first gap we're going to tackle is 1/16 of an inch. And I'm going to use an 030 MIG wire. I've got my machine set at 175 inches per minute at 16.5 volts. I'm going to check these settings on my first weld to see if it's too hot or too cold, see what I need to do there. My technique is also going to be pretty simple. I'm going to drag the gun, because if I pushed it, well, the wire would just go through the gap. I'm going to drag the gun and not going to weave it back and forth in order to keep the heat as low as I possibly can. Let's see if it works. All right, it made about 1/2 inch and then I blew this big hole in it. So now I've got to go over to my machine and mess with my settings. What do I do? Do I go down with my wire feed speed? Do I go up? Do I mess with my voltage? Well, let's remember the theory here with MIG. Wire feed speed controls amperage. So if I turn that down, I'll have less punch into my material. So I am going to turn the wire feed speed down. Also, if I turn my voltage down, that's going to narrow my bead profile. This bead is pretty wide, so I know I can narrow it up a little bit more and make sure that I can focus and concentrate all the material right in the middle of the weld. Now, how much am I going to turn it down? I'll just try 10% of the wire feed speed and 1/2 volt, and we'll see what happens. I have my wire feed speed set at 157 inches per minute and 16.5 volts. And not only was I able to fill in the hole that I blew with my first weld, but the weld, when I terminate it, has a nice crisp edge here, so I know I have my settings correct. But I still don't want to just go all the way down the line, even if I have correct settings. If I do that, that's going to overheat the parent metal, and then I'm just going to end up blowing through. So I only want to weld in about 1/2 inch to 1 inch at a time. Another factor in that is minimizing warpage. I don't want to go from point A to point B and warp the whole plate. So I'm going to stop my welds intermittently and let everything cool down. I'm also going to take some welds and go the opposite direction that I've been going. So I've been going from left to right here. So now I'm going to go right to left. That will counteract the distortion of this weld, and we'll end up with a flatter plate in the end. That turned out great. I think our settings are nice. We put a very low amount of heat into the plate. I did weld from this direction to this direction to try to counteract the distortion that I'm getting. I'm still gonna get a little bow in the material, but that's okay. I can fix that post weld. I'm gonna let my parent metals cool, and then we're gonna weld out the rest of this. The next gap that we have is 1/4 inch wide. Our settings of 157 inches per minute at 16.5 volts may work. I'm not sure. I'm gonna have to just strike the arc here and walk the gun back and forth between the two parent metals. This gap's so wide I can't just keep the gun in the middle like I did with the first one. But I'll probably have to end up turning my wire feed speed down. The larger the gap, the more likelihood that weld's gonna sag in the middle. So we gotta cool things down to get a little bit more surface tension. Let's see how it goes. As I expected, our settings were a little bit too much here. I've got too much amperage, so too much wire feed speed. How do I know that? Well, I can see the edges of my material here. I can start to see them getting chewed away on the sides. So I know I'm just getting excessive amount of penetration. It's really trying to chew into my parent metal. That's not my goal here. My goal is to span this gap. I'll get penetration on the sides. I'm not worried about that. But if I would have kept going, this hole would have just gotten larger and larger and larger. All right, so now we got to turn the wire feed speed down, but where do you go? Now I'm just gonna go 10% again, turn down by 10%, and turn my voltage down just a little bit, maybe 1/3 of a volt. That's a very small little integer. And I'm just gonna go down in small increments until I get the results that I want. I turned my wire feed speed down to 140 inches per minute, and my voltage was at 16.2 volts. And I can see that it's not cutting so far into that parent metal as we saw with that first one. So it's getting better, but I could only bring it out to here and I could still see it wanting to pull those sides apart. So I'm gonna go even further down with my wire feed speed. $130 inches per minute and 15.7 volts. Now I was able to get 3 beads in before I was figuring that this was a little bit too hot. I'm looking at the puddle before I make my next weld, and if it's still glowing orange, I wait until it dims out almost to gray, and then I know I can stack another one on top of it and stack another one on top of that. I think I'm still gonna come down even further with my wire feed speed because I still want this a little bit cooler. I could check the backside here, and yeah, it's punching through the backside, but only by about 1/8 of an inch. I'm not gonna come down 10% with my wire feed speed, just maybe 5 inches per minute, so 125 inches per minute at 15.5 volts. If everything looks good, I'm going to go ahead and make small welds, let them cool, small weld, let it cool, small weld, let it cool, and see how far we can get down the line. That time I was able to get about 5 or 6 welds in there. I wasn't really counting, but what I was looking for here was the sides, my parent metals, making sure that it wasn't getting chewed out too much on the sides. I was also watching the glow of the bead. If the bead is glowing and you can see it through your hood, and then it starts to dim out, then you know you're ready to make your next weld. But eventually what'll happen is that glow will just continue, and it'll take quite a long time for it to go back to gray. This is how I know I need to stop, let everything cool back down until I continue again. It's all done. You can see here that my heat affected zone got a little crazy at the end. That's because I wasn't being patient and I kept rushing through it because I wanted to show you the end product. Also, look at these little holes every once in a while in the weld. Those are termination craters or little pinholes that you get when you start and stop the weld about 800 times like I did here. Those are pretty easy to get rid of. All you'd have to do is just add another little spot of material on top of them. But if you want to avoid them in the first place, just every time you stop the weld, take a look at where the crater is and then make sure that that next weld you're putting on top of it caps over that crater, like I did here. Here's the big gap here. Now, of course, in this type of situation, it would probably be better just to cut a strip of material and place it in there and then weld it on the sides. That would be far easier than trying to fill up this gap. But hey, you're watching a video about how to fill a gap, so that's what we're gonna do. Now, my settings of 120 inches per minute at 15.1 volts may work here, but I'm really gonna have to exaggerate left and right. But that's actually giving me a little bit of advantage because I'm really getting that arc heat away from either side. So I might be able to walk it back and forth a little bit faster, or get a little more weld down than I did with that 1/4 inch gap. The thing that's fighting me the most here is gravity. Gravity is gonna wanna pull that weld in the middle and eventually just drip the whole thing out. So I just gotta watch my sides and watch the glow of the puddle in order to be successful here. it worked, but I think I still need to turn the machine down a little bit more. I noticed a lot of the parent metal on this side is getting chewed out, so I wanted it a little bit colder. Now, there is an easier way to do this. If you're able to turn your material to where it's vertical and weld this vertical down to where gravity's helping you pull this way, that's quite a lot easier to do than how we're doing it here. But let's keep going. "110 inches per minute at 14.5 volts, and things are looking good. I'm not chewing out the sides, but the thing is, it's taking quite a long time to make those layers in between. I'm having to wait a long time in between there, and I know patience is gonna be the key, but I can use another trick here. I'm gonna use this piece of 1/4-inch aluminum. I'm gonna fashion this so it's sitting down on my material and acting like a heat sink. Now, I could just get my weld done a little bit faster. If you have a gap larger than about 1/2 of an inch, it makes a little bit more sense to cut out a piece of material and use it as a filler. But with the right machine settings, a little bit of patience, you can fill any gap. Thank you for watching. If you like our videos, please subscribe. And if you want more information on General Air Service and Supply, head over to our Facebook page where you can like and follow us there.